Right, we learned in the routing class that routers are the device that can take a traffic from one network to another network. So you definitely need a router because router only got multiple broadcast domain, meaning multiple networks. This is 10 broadcast domain. This is 20. Each port on the router belong to different broadcast domain. And moving the traffic between different broadcast domain is what we call it as routing. Now, if you take a switch, each VLAN will be in different network, different layer 2 group, different broadcast domain. All that is in blue belong to VLAN 10. All that is in purple belong to VLAN 20. Now pinging between this computer and this computer is made easy through router. So A, who has got 10.0.0.1 with a gateway of 10.0.0.20 can ping B, which has got 20.0.0.1 whose gateway is 20.0.0.20. In the real world, this is how the physical connectivity also will appear. We keep one device over the other on the rack, and we take connection from a switch and connect to the router. This is one style. If you have just two networks, this is enough. Inter-VLAN routing. This is VLAN 10, this is VLAN 11. Pinging between VLAN 10 to VLAN 11 is possible now. This is one design. But when we have many VLANs, you need many ports on router, which is not mostly seen. Not seen. I have VLAN 12, 30.0.0.1. And the gateway I want to have is 30.0.0.20, but there is no port on the router to have as a gateway. There is no port. So what are we going to do? We are going to have trunk on a router so that instead of keeping separate link for each VLAN on a router, you can have only one link sharing between these three VLANs. How can one port on a router become a member of three broadcast domain? That is what subinterface does. With the help of subinterface, we can create multiple broadcast domain out of one physical port. So what we are doing, we are going to take only one wire, not separate wire for each VLAN. We are not going to take like this. We are going to have a trunk port on the router, sorry, on the switch, and we connect the trunk port with the wire to the router and the switch. But the problem is the router cannot negotiate trunk. No auto negotiation because you are breaking down the physical interface into multiple virtual interface. It's only one port actually. So it appears now as 3 ports. Just one physical wire, but named now as Ethernet 0.1, 0.2, 3 sub interface. It's actually Ethernet 0 port, but we have broken in 3 logical pieces. As I said, these routers cannot negotiate VLAN using any .1 queue. So you have to manually configure trunk here, and then this side you have to say what encapsulation tag need to be added for the traffic that is coming with this layer 3 address. Anything that comes with layer 3 address 10.0.0 should be tagged with VLAN 10. They should be tagged with VLAN 11. They should be tagged with VLAN 12. So when a router receives, first thing they see what network the source is coming from. Telnet. Oh, okay. Then what tag it is coming with? VLAN 10. Okay, good. Matching. VLAN 10, network 10. Traffic is coming from PCA. Matching. Okay, what network the traffic should go? 20.0.0.20. Sorry, 20.0.0.1. Okay. Then I'm going to remove the tag VLAN 10 and I'm going to put VLAN 11 because 20 is in Ethernet 0.2 VLAN 11. It tags VLAN 11 and send the traffic here, and this guy will put the traffic in this broadcast domain, and that's how it comes delivered here. Tagging matters even here. So we see here the VLAN numbers are encapsulated before sending out from the switch over the trunk port, decapsulated, removed on router 1, again encapsulated on router, sent to switch, decapsulated on switch trunk port, and delivered to the destination. So router also encapsulates VLAN. Advantage is you don't need to have too many physical wire or physical port on a router to achieve this. Disadvantage is if that one single link goes down, This goes down, no routing at all. Switches can't do routing. So you see here, a shared interface is good, but there is chance of single point failure. There is also one more disadvantage here. If there is too much of traffic going between VLAN 10, 11, 12, every single packet should go through this single wire and come out on the same wire. Go like this and come like this. Go like this and come like this. So going and coming is on the same link. Usually it goes like this and comes out on another link. But when you have all the traffic for all VLANs going and coming on the same wire, see how much of traffic will be on that single link. Too much. So the delay for the entire network happens because of this one single narrow path. Of course, it is narrow. Earlier, it was only for um, ambulance, for fire service, so separate lane. But now you got one common lane in which the medical ambulance, the fire service, everything goes and comes. Of course, there is going to be a delay in all these services because you have only one link to share with many services. Okay. But the routing will happen in a small network. It is okay. This won't have big impact the performance. Only in a large network the performance deprivation will happen. We call this as normal routing with router. This routing over this trunk link is called as router on a stick. Router on a stick. Router on a stick. That's how the name is given. You see, it looks like on a stick, and router, the big head is attached on the top, appearing as if anytime it will fall down from the tip of the stick. So, yes, it's possible for the single point failure. The link may fail at any time because it's single link for all traffic. Not at all recommended. No redundancy. Nothing. All VLAN will be shunned just like that if that link goes down. No VLAN traffic from one VLAN to another can pass through. Okay, what is next? We have seen the drawback and the benefit of this. Benefit is you don't need to have too many ports on a router to do this inter-VLAN routing between many VLANs. Here I've drawn 3 VLAN. Even if you have 30 VLAN, this will work. You no need to have 30 ports on the router. You no need to have 30 dedicated ports on a switch. Single link, trunk link, instead of 30, you have only one. This is an advantage. Cost is also low. Disadvantage, as we saw, single point failure. Performance goes down because you have a shared bandwidth. So what is the best solution? In a large network, instead of we buying this two separate box like a router separately and switch separately, we will buy one single layer 3 switch. The advantage is on the rack, it's not two devices, it's just one device to manage. Here you have two separate devices to manage, two separate consoles. There it is single box, multi-layer switch. Basically, it is same picture. But it's one box. You have inside a router engine inside this box, as well as switch engine, layer 2 and layer 3 engines on the same box. Now, this is a motherboard. What you see, the green rectangle is a motherboard inside the box. Then how do you have this sub interface? It's not a physical port. If it is physical port, we create sub interface. So what we configure is we configure a logical port. And we call it as SVI, VLAN interface VLAN 10. We'll have this gateway 10.0.0.20, interface VLAN 11. We'll have 20.0.0.20, interface VLAN 12, 30.0.0.20. So instead of creating sub-interface, we create a layer 3 switch to virtual interface. For all this VLAN 10 member, this one SVI belong member owner. So we see here, you just create SVIs. That's it. We create SVI, switch to virtual interfaces. Very easy. SVIs. Each SVI we give an IP address, same like we used to give on the physical port or the sub interface. So when traffic enters with a different network address on the switch, what they do is, as soon as they see different network, they send it to the routing engine. Routing engine puts them in different broadcast domain. Each broadcast domain has got its own SVIs. And we call this as SVI because the virtual interface inside, it's not a physical interface. At least in the router on a stick, you had one physical interface. Here, the layer 3 interface is totally virtual, and traffic is entering in a switch port, going through the virtual interfaces for the routing. Right. The disadvantage of this is only one: costly. All right. The advantage is you don't have a bottleneck. You don't have this wire. Some common one single motherboard. So there is no single point failure. The other advantage is motherboard speed. If motherboard is fast, your communication is going to be fast. Whereas here, switch processes, and then router processes, and then again switch processes, and then sends out. Here, that's not the case. Traffic enters, process goes out. So the time taken also very less. Efficiency also more because it's motherboard speed, not Ethernet wire 10 gig, 10 meg or 10 gig or 1 gig. If motherboard is 1 TB speed, then your communication also will be the same. Any question? Very well, it will work. It will work. We can have such lab in our lab. We'll do that tomorrow. Remind me when we do the lab. So your question is, we have in one switch, there's 3 SVIs, and then we got a trunk port here, and we connect to a router here, and we have sub interface, and then we have some one pinging from A to alpha. Yes, it is. It's going to work. It will work. So it is like you mix both SVI and router on a stick in a topology. It is possible. It will work. Fine. No, 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 not like that. All right. Welcome. So I will